I happen to think Wasm is kind of special because it's a low-level language. It's really nearly as low level as ARM or x86 assembly. Working with it is much, much nicer than working with any kind of assembly language. We've seen huge speedups in the parse times now for this. So the new versions based on WebAssembly is sort of 40 to 50% faster and uses about 20% of the memory that we did before.
Hello and welcome to another episode of the Web Dev Podcast. Today on the show, we are going to dig into one of those technologies you hear about all the time, but it's not often that you actually see it in action. And I want to find out why that is, how we can take advantage of it. Today, we're going to be talking about WebAssembly. So WebAssembly, for those of you who are not familiar with it, is a way for people to build really, really advanced stuff that lives and runs completely in the browser. I only sort of understand what it talks about, so I brought along an expert to help us tease it apart and show us how we can take advantage of it. So I want everyone to please welcome to the stage Patrick Dubroy. How you doing, Patrick?
I'm doing fine. Thanks. How are you?
I'm doing great. Thank you so much for being here today. We've talked about WebAssembly on the show a couple times in the past. Historically, we've been kind of like using a framework that'll convert something to WebAssembly, or we've been kind of doing something WebAssembly adjacent, but we haven't dug into really the nuts and bolts of WebAssembly itself. And so I'm really excited to have you on to talk about that because you quite literally wrote the book on this. Am I correct?
I wrote a book on it. Yes, that's right.
Yeah, so maybe just start there. Give us a little bit of a background on who you are, what you do.
I'm an independent programmer and researcher. I'm the maintainer of a open source library called Ohm.js, which is a parsing toolkit for JavaScript and TypeScript. And I started experimenting with WebAssembly actually in that context, and then decided to write a book about it with my friend Mariano. So we have a book called WebAssembly from the Ground Up. Yeah, the idea is to take you down into the details of WebAssembly by helping you to build a very, very simple compiler in JavaScript. For all that, I spent a few years at Google on the Chrome team and also on the Android team.
So at a very high level, can you just give us the elevator pitch on like what is WebAssembly?
I think I'll bring in some of the history, I guess, is also helpful to help explain it. So yeah, at a high level, WebAssembly is a way to take native code, typically that was, maybe written in C++ or Rust or something like that, and run it efficiently and safely in the browser. And historically, the first people who were trying to do stuff like this, we're working with games. One of the big use cases was to take games that had been written in C++ and get them working in the browser. And the way that the first kind of viable way of doing this was something called ASM.js. And this was basically a restricted form of JavaScript that the browser, it began in Firefox, but later other browsers added support for this. They would sort of, if you wrote your JavaScript in a certain way and you used use ASM string tag at the top, it's kind of familiar because this sort of thing is coming back now, putting strings at the top of your JavaScript to give it special meaning. But the JIT would recognize that this was a restricted form of JavaScript and could do a bunch of optimizations that it couldn't otherwise do in JavaScript. And this worked pretty well and kind of proved that the kinds of things that you would use C++ for, you could get a JavaScript JIT to, give you nearly the same performance that you would get running that code natively. The big problem with ASM.js was it was quite large. So if you took a game and compiled it down to this format, you would have huge bundles. And so WebAssembly kind of then was an attempt to say, hey, can we do the same idea? Can we take the same idea of being able to ship code, native code to the browser and have it execute it safely, but do it in a much more efficient way? So it's basically an efficient binary format for shipping instructions to the browser. and the JIT can then turn those instructions into native code for your CPU. So it's a a platform independent representation that gets shipped down to your browser, conceptually similar to Java bytecode or something like that. And then, your JIT will compile that down to either x86 or ARM machine code.
To hear you describe that, it brings me back to what I started saying before we did the history, which is that it feels to me like most of the people I see really leveraging Wasm are pretty deep in the stack. Are people would kind of get the like, oh, you're pretty hardcore when you talk about what you do for work, and hearing that you've worked on the Chrome team, that you're sort of in the browser world and pretty deep in it. Is that, do you think, an artifact of like Wasm being hard or I guess advanced, or is that an artifact of like, because you're in that world, if you're deep in the browser, you just get exposure to it, therefore more willing to try it?
I don't think it's that it's so hardcore and difficult to understand, because otherwise I wouldn't have written a book about it. That's part of our goal with the book, was to sort of try to open that world up for people. And the reason, one of the choices we made very early on with the book was to put all the code in JavaScript. And we had thought about whether we should do it in Rust instead. You see a lot of people who are working with WebAssembly are working in Rust. And we chose JavaScript because we wanted to make it as accessible as possible. But yeah, I think you're right that sort of either people are working with Wasm by writing their code in a language that simply compiles to Wasm, right? And then you're not really working directly with it in the same way you're not working with ARM just because you have a MacBook, right?
Right.
The code is ultimately ARM machine code that's executing, but you're writing your app code in some other language. And so I think a lot of people work with Wasm in that way, right? They have a compiler which produces Wasm in the end, but they're not sort of interacting with it on a very low level. But yeah, I happen to think Wasm is kind of special because it's a low level language. It's really nearly as low level as ARM or x86 assembly, slightly higher level, but working with it is much, much nicer than working with any kind of assembly language. So the tooling that you have is much nicer. And just the whole environment is, things are easier to debug. You have a validation pass, which if you screw up in your instructions will tell you that you messed up rather than just saying segmentation fault or something like that.
Oh, yeah. So then let's talk a little bit about kind of practical application of this. So I think maybe the other gap that I've felt in my own like world of encountering problems I would solve with Wasm, a lot of times when I'm thinking about how to solve a problem, WebAssembly doesn't ping as a valid solution. I think that's due to my own limited understanding of like where its sweet spot is, because if I might not even write about this, the only major implementation of WebAssembly that I'm aware of, I believe, is Figma. Is that correct? Is Figma WebAssembly?
I think large parts of it are in WebAssembly, yes. I think Adobe Photoshop, the web version of that, also is.
Oh, right, yeah.
But I think one of the things about WebAssembly is that people just don't tend to talk about it when they're using it. It's not really a user feature, right? You often hear, we made our site, we made our compiler, we made this or that 10x faster, or whatever the case may be. And they don't necessarily tell you that it's because of WebAssembly. But under the covers, there are, many libraries for, say, image processing. It needs to be a certain type of code that will benefit
Yeah,
JavaScript
and maybe we should
just
run through that. Like, what are kind of like the core use cases where it makes sense to reach for WebAssembly because you couldn't really do it in JavaScript, and then you don't necessarily want to have to fire it off to a backend server.
Yeah, I think there's a few major use cases. So one of them is you have some existing app, right, that was not written for the web, an app or a library that was not written, in JavaScript or for the browser, and you simply just want to use it. So a lot of people have that kind of use case. So you have, say, physics libraries that were written in C++ for games, right? And someone wants to use them in their web-based game. Or, I mean, I've even seen sort of like layout libraries, UI libraries. So there's a popular UI library called Dear ImGUI, which is used in games, does this sort of immediate mode GUI style, which a lot of people really like. And you can use that on the web just kind of for free because of Wasm. So that, that is one big use case. Another big use case these days is actually cloud computing. So for serverless environments, WebAssembly, like a lot of the providers already had JavaScript runtimes, like V8 for writing serverless functions, right? Like the first version of AWS Lambda, I think, if I recall correctly, only supported JavaScript. And because V8 as a runtime also supports WebAssembly now, that now means that kind of for free, companies like Amazon, who are already letting you write Lambda functions in JavaScript, can now say, oh, you know what? Any language that targets WebAssembly, you can write your Lambda function in. And there's some benefits for the for the cloud computing for the hosts. There are some concrete benefits of WebAssembly, basically.
Well, because if you take your serverless functions, for example, and you compile them into a WebAssembly format, then you're getting a more efficient final bundle, right? Like because you've sort of taken it down to this more low level. There's less work to be done by the server during the serverless call. Is that a correct assumption?
It depends, I guess. It's not always less work. Often it can mean faster startup time. So like if you look at the pure top end speed of code, what the highest optimizing tier of the JavaScript engine can do is extremely fast and is unlikely to be faster than WebAssembly. So if your JS code has the right shape, Turbofan, which is the the optimizing compiler in V8, can make it crazy fast. And your WebAssembly is not going to be faster. But the WebAssembly, getting to that top level of performance in WebAssembly is kind of simpler for the runtime. It's also usually it's pre-optimized code. So if you have code that was produced by a C++ compiler or the Rust compiler, that final code goes through a relatively long optimization pass to produce the final binary that you upload. Many of the same optimizations V8 would have to do on your JavaScript code anyways, and they would be expensive.
And if you're right, if you're doing that on something that's like in a loop, it's worth it because in JavaScript it's like a little less work to get it, and it does the one optimization path, and then it runs it 1,000 times, and great. But like a lot of times we're sending one image to be like transcoded, or we're sending one thing that needs to be posted to a bunch of different places. And so if we have that long optimization pass and we only do one operation, it's, we're kind of wasting time. And you're wasting compute if it has to fire up every time. Whereas if you have it kind of pre-optimized and send up a binary, then if 1,000 people do one pass, you don't have to run that optimization loop for every call. Am I kind of understanding what we're getting at here?
Yeah, absolutely.
So it starts to really show its strength when you think about like distributing these systems. When you take something online and you've got a lot of people doing something, and I think this is why you see like Figma spent so much effort on getting the Wasm stuff going, because you were trying to run all the different things that you can do on Figma in JavaScript. That would be a nightmare. Like I don't think that app would run at all if you were trying to just run that all in client-side JavaScript. So I can see, and that again kind of points to these sort of like heavy-duty use cases. But also, I see your co-author Mariano is in chat, and he was talking about we can use it for image and audio and video. Transformations like format and size and quality, listed off Shopify and a flight simulator, which is kind of fun. And then rule filters for Nginx, Envoy, Cloudflare, and Fastly. So all of that kind of points to like it's really good at what I would consider to be utilities. Is that maybe a safe bucket to put this in? Like if you're writing a lot of code that's like, we have a service, the service requires us to take input from one place, transform it in some way, and then put it in another place, and that happens lots and lots of times by lots and lots of people, then that transformer layer is probably a good thing to consider. Is like, could we make like less work for the computer and faster to execute if this were to be like converted over into Wasm? Could we maybe move this off of a server and into the browser to make it more performant for the user if it's something like image transcoding? Like there's some interesting considerations there in terms of what work are we doing? And I know, for example, I work in media, and a lot of times I feel like I am uploading something to a server where I then have to wait for that server to get through optimizing my media or doing whatever it is that it does. And then that has to get sent all the way back to me to then be available in my front end. And if that were to happen on my browser, like I do it often enough that would actually be a huge cumulative time savings over the course of a year to not have to upload a 1.5 gigabyte file every time I need to make a change to it.
Yeah.
That's me sort of like applying my own problem space to like where this feels really interesting. Do you have any like favorite apps that you've seen or like favorite case studies of where this really made a big difference?
Well, my favorite one right now has to be probably the parsing library that I work on, which I mentioned earlier is called Ohm.js. And the basic idea is there's all kinds of reasons why people, might want to either quickly parse some existing language, or in many cases, people design their own language. So that was the original reason we created Ohm, was we were doing programming languages research and wanted to be able to try out new syntaxes and quickly build an interpreter or compiler for it. Shopify is also using this library in their product. So they have a template language called Liquid. And when you design, you can edit your themes for your store by editing this template language. And, they want to be able, all their developer tooling, VS Code plugins and things like this use this library Ohm that I'm maintainer of. And when we originally created Ohm, the original implementation was all in JavaScript, and it wasn't done in a particularly efficient way. And for the past year or so, I've been working on a new version, which takes, so users write a description of their language, a grammar, which describes, what are the valid syntactical forms in the language. And it used to be we would use JavaScript to interpret that grammar, which would then let us parse some input. And we switched to compiling those grammars to WebAssembly. So we get the same benefit that you're talking about, that like we can do a bunch of work up front and produce a optimized thing. And then the JS engine at runtime can do a lot less work, sort of making it fast. But we've seen huge speedups in the parse times now for this. So the new version is based on WebAssembly, is sort of 40 to 50% faster, and uses about 20% of the memory that we did before.
Yeah.
So that has been that right now is, I think, my favorite. My favorite example. I think there are probably a lot of JavaScript libraries out there that could selectively look at parts of the library that are very compute intensive, and could get benefits from switching those things to WebAssembly.
So one practical question about this, like let's say I am the maintainer of an open source package. I realize something I'm doing is a great target to be moved over into WebAssembly because I can see some huge savings. Once I've made that change, what does that mean for downstream users? Like if I, for example, have published this on NPM, does anything does the person downloading that package, do they have to do anything differently, or is this sort of a completely behind the scene, like no notice change, except that everything suddenly performs a little better?
Yeah, good question. It depends. I think you can certainly make it. You can do it depending on the scenario. It can be done in a way that sort of nobody notices, and it is often done that way. There are a few gotchas around working with bundlers where if you're a library author and you start using WebAssembly, the people who are using your library may need to modify how they do the startup, like how they instantiate the library. And this just has to do with some of the complexity in how bundlers deal with shipping binary data.
Okay.
So there's to be honest, there's no good reason why it's like that. But the fact is that today, it could be that you have to tell the users of your library. I mean, the change can be as simple as there's an asynchronous init that has to happen before you can use the library, right? So before you did import lib, and then you called lib.do something, and maybe now you need to say import lib.init, do something.
I got it. Okay.
Await lib.init.
Okay, so there it can cause a little bit of a shift. It would probably be it's obviously going to be like a major version breaking change if you make that switch over, which seems reasonable. And there might be a little bit of a migration guide to getting from one place to the other, but it's not going to be like, hey, surprise, you're no longer using JavaScript. You're now using this other thing that you have to, make sure you have Python installed, or make sure you've updated your Xcode or whatever it is. You can still just continue to operate inside of your normal runtime. You're not having to modify your DevTool stack or start thinking about it as being a different sort of thing. It's still, as far as you're concerned, it's still a node library or a node package, and you're going to continue to use it. You just might have to a little bit more setup to get it running. Yeah, exactly. Okay, no, that's great. Any other question I have, I feel like is going to be a little easier to talk through hands-on. So I feel like I want to get to the companion episode we're going to do, where we're going to get into some pair programming on Learn with Jason here. But before we do that, is there anywhere that you want to send people who want to learn more about assembly and how this works? I believe there's a website for the book, right? Yeah, that's right. The website is wasmgroundup.com. People could use the code Jason if they want for the book. Is it like a discount code? Yeah, we have some free chapters on there. There are a couple of interesting blog posts as well that are just sort of follow the same theme of the book of trying to get you familiar with WebAssembly by really getting your hands dirty. Nice. Well, cool. So with that, I think I'm gonna take us out, and just thank you so much for spending some time with us today. I really appreciate it. Remember, everyone, there is a companion episode of Learn with Jason where Patrick and I are going to get hands-on building something with WebAssembly. So if you want to see how it works, make sure you head over to CodeTV website or YouTube and look up Learn with Jason. This has been the Web Dev Podcast. Make sure you like, subscribe. It's on all your podcatchers. You can get it in video or audio format. We are everywhere that you would probably listen to a podcast. Patrick, thank you again for spending some time with us today. My pleasure. Thanks for having me.